on that page 92 of your packet is going over the amount of mortar needed for a certain number of blocks or bricks. So for example, if we're looking at just let's do a standard brick, which is a 4-inch by 2 2/3 inch by 8-inch bricks. This is the top one in that big table now at the bottom of page 92. You'll see that the number of bricks per 100 square feet of wall is 675 bricks. The amount of mortar per 1,000 bricks depends on the size of the joint, obviously. Bigger joint, a 3/8 inch joint is standard. A 1/2 inch joint is sometimes used for more decorative applications. If it's structural, usually it's 3/8 inch joint is where they leave it at. So if it's a 3/8 inch joint, it takes 8.1 cubic feet of mortar per 1,000 bricks. If it's a 1/2 inch joint, it takes 10.3 cubic feet of mortar per 1,000 bricks. So how does all this stuff work out? Well, let's say that we have a wall we're going to do you're putting in an estimate on a house, a bid on a house, and this house on the front of it has a brick ledge. We have a window and a door out of it. And it's just going to be along this side of the house, not wrapping around at all. So the length of our house here is 48 feet, and we're going to make this a 3-foot door. The height of the ledge, we're going to make it 4 feet high. We're going to ignore any loss for this window. The reason we're going to ignore that is you're going to have to cut bricks to fit in that window. You're going to have to cut bricks to fit in the door. So whatever's lost for that window, we're probably going to use and waste anyway. So we're not going to subtract anything for that, but we will subtract for the door. So what we have for area here is we have a brick ledge that's 4 feet high, and its total length is what? 45, there you go. 48 minus the 3 feet for the door. So that's going to give us 180 square feet of brick. If we're using that 4 by 2 2/3 by 8-inch brick, there's 675 bricks per 180 square feet, or for 100 square feet. So what we have is 675 bricks per 100 square feet. How much is that going to be for 180 square feet? You're right, you could have just done 1.8 if you saw that. So 675 times 180 divided by 100 is 1,215, it looks like, brick. So that's how many brick it's going to take. Assuming that since this is decorative, it's a 1/2 inch mortar joint. Up here it said 10.3 cubic feet of mortar for every 1,000 bricks. So 10.3 cubic feet per 1,000 bricks. How much is that going to be for 1,215 brick? So we're going to do the same thing. The 1,215 times 10.3 divided by 1,000. We get, should have been 12.51. I got an extra 0 in there. 12.51 cubic feet of mortar is what it takes. Everybody follow that so far? So then, how much of each material do we need to order? Well, let's say since this is decorative, we're going to go with a type, let's go with a type S. We want it to have a little bit more strength since it's going to be a cold weather application. So for type S, the amount of cement, if you look at that table on the first page, is 0.21 times your cubic feet of mortar. So 12.51 times 0.21 is 2.63 cubic feet. The amount of lime is 12.51 times 0.1. So that's going to be 1.25 cubic feet of lime. And then sand is at 12.51 times 0.94. Which is going to give us 11.76 cubic feet of sand. Now, sand is typically converted into cubic yards. So we're going to divide that by 27. You get 0.44 cubic yards. So just under a half a cubic yard of sand. Any questions? Notice, by the way, we're still not looking at amount of water for these, because the moisture in the sand and the type of lime, whether it's a hydrated lime or a dry lime, whatever, all make a difference there. So there's your materials. So let's take a look towards the back of this thing. Let's look at a problem like, oh, I don't know. Let's look at a problem like number 18. Now I want to look and see if any of these charts give us a waste factor. 25% should be added for the total amount of mortar needed. That's pretty typical just because mortar is sloppy, gets bounced around. Is it giving us any sort of addition for brick? It is not. So we're just going to assume you guys are not clumsy, you don't drop any brick and break them. Okay? Why is everybody looking at Jasper? Okay, so number 18. This building has a 24-foot high single wide. So where my one went there. Single width just means it's single thickness, so one layer. 24-foot high brick veneer wall. They're using the 4 by 2 2/3 by 8. 4 by 2 2/3, by the way, is this brick right up here. That's 4 by 2 2/3. It's your standard module brick. The reason of course, 4 inches is pretty obvious, and 8 inches is pretty obvious. It takes 3 of them to get to 2 feet. The 2 2/3, if you stack, 4 of them at 2 2/3 inches, if you stack 4 of them, no, if you stack 3 of them, it comes out to 8 inches of height. That's where that 2 2/3 comes from. So anyway, we need to find our area here. This building is labeled as 50 foot 8 inches by 70 foot. So to find the area of the wall, we're going to find the remember last semester we talked about lateral area? This is why we did it. We're going to find the perimeter, which is 70 plus 70 plus 50 foot 8 inches is 50 and 8/12, or 50 and 2/3. So that adds up to 241 and 1/3 feet of perimeter. So the wall area is that 241 1/3 times the 24 feet high. Giving us 5,792 square feet of wall that needs to be covered. So we're using, again, 8 2/3 by 8 inch, or 4 by 8, 2 2/3 by 8 inch brick, which means there are 675 brick per 100 square feet. We need to figure out how many that's going to be for 5,792 square feet. Giving us what, 39,096. Brick. So now we need mortar. It's telling us 1/2 inch mortar joints. So it's telling for 1/2 inch mortar joints is 10.3 cubic feet per 1,000 brick. How much will that be for 39,096? Cross multiply and divide. That is 402.69 cubic feet of mortar. What did it say to add for a waste factor? 25%. So we're going to multiply that by 1.25. So we need 500. We're just going to call it 503 cubic feet of mortar. So this is type S. So for type S, to find the amount of cement, it's going to be times 0.21. Which is 105.63 cubic feet of cement. For lime, it's times 0.10. So that'll be 50.3 cubic feet of lime. For sand, it's times 0.94. 503 times 0.94 is 472.8 cubic feet. And of course, that's going to get converted into cubic yards by doing what? Divided by 27. Good. So it's 17.5 cubic yards of sand. So that's your materials needed. You need to order for that job, or you need to price for that job at least. I'd probably price 40,000 brick, 106 cubic feet of cement, about 51 cubic feet of lime, and about 18 yards of sand. Throw them at kids passing by. A lot of times they get broke. I mean, these things, it doesn't take much to drop them and they get cracked. Sometimes you can take those broken bricks and saw them where you need a 1/2 a brick, but a lot of times, at least half of it's still going to be waste. Have you guys talked at all about modular construction? A little bit? Okay. They use the term CMU, concrete masonry unit. There's also CMU can stand for construction modular unit. Modular in construction, the main modular unit in construction is 4 feet. The reason 4 feet is a modular unit is because everything comes out at 4 feet. 16-inch block comes out at 4 feet. Takes 3 of them to get 4 feet. 16-inch studs come out at 4 feet. 24-inch studs come out at 4 feet. 8-inch brick comes out at 4 feet. 4 feet is your most common modular, modular dimension in construction. So you try to design things with dimensions that come out on 4 feet. Now, have you guys talked at all about spacings other than 16 and 24? 19 and 3/16, or 19.2. That is not modular at 4 feet. It is modular at 8 feet. That's pretty much only used for floor trusses, floor joists. I've seen it used once for roof joists, and it was for attic trusses, or for roof trusses, I should say. It was for attic trusses, and so the floor didn't have too much give. That's actually something that's really kind of strange. As a contractor, I would really like to see attic trusses set at 16 inches, so when you put flooring in, you don't have the flex in the flooring. But it all depends on what truss company you get designed with. Some truss companies will design them, it's a roof truss, so it gets designed at 2 feet, period, and you end up having to go back through and bracing between the trusses or using extra thick flooring to avoid that flex. Usually use two layers of tongue and flooring to keep it from flexing. Others will actually put that roof spacing down to 16 inches so you don't have that flex in your attic flooring. And then they can actually build a lighter truss because they're closer together. That also allows you to go down to a 7/16 roof sheeting rather than 1/2 inch. So because you're closer together, so you don't have to worry about the flexure. I still would never go down below 1/2 inch. In fact, on a 2-foot truss spacing, I a lot of times used 5/8 inch roof sheeting just because you didn't get that bounce in it. Any questions? I'll let you guys have the next 20 minutes or so, polish up that packet. Do you guys have any questions on the worksheet I gave you on Tuesday? Okay. Let me see what else is coming up here. I'm going to pause.